Page 2. Suppose you're tossing two fair dice. A is the sum of 6. And it says show the sample space, which means I wanted you to think about either drawing this or some other method of showing all the possible outcomes, of which there are 36. You should be well aware of that by now. "36 intersection points, and sum of 6 would be 5 and 1, 4 and 2, 3 and 3, so on. And B is doubles. That's 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. So then it says fill in the table. How many ways are there to get both? Well, there's 1. Now, some people wrote 1 out of 36, which would be the probability. That's okay. I'm just going to put the 1, but you could have put 136 there. So A is rolling a sum of 6. There's 1, 2, 3, 4, 5, and we have 1 that's both, so there's 4 more that are not with X's in them, not B, but in A, making a total of 5 that are in A. B has 1 that's in both and 5 others, making a total of 6. And since there's 36 outcomes total, and we've got 5 and 5 is 10, so there must be 26 more over there, making 30, 36, and 21, and 36. Now, you could have put all these divided by 36 and made it a probability table, and that would have been fine. Okay, so now I've done B, C. Probability that it's not B. Rolling doubles is there's 6 of them. Not B would be the other 30 out of the 36. And you can reduce that to 5/6 if you want. A or B. So I'm going to take all of A, 6, all of B, 5, minus the overlap, 1. So 6 plus 5 minus 1. Which comes out to be 10 out of 36, or 5/18 if you reduced it. A or, I did A or B. A and B, that's just the overlap. There's only 1 of those out of 36. And A given B. So if B has occurred, that's doubles. There's 6 of them. How many of them have A? Only 1 of those. So that's 1/6. 1/6 chance of getting that. 5. Distinguishable permutations of mathematical. So we got 12 letters. So there's 12 factorial ways of arranging them, but not all of them are distinguishable. Since there are some letters that are the same, like 3 A's, I have to divide out how many ways there are to switch 3 things around, and that's 3 factorial. And there's 2 M's, so I have to divide out how often I can switch those every time. And there are 2 T's. And there's no doubles of anything else, so I got to work that out. So that would be 12 factorial divided by 3 factorial. 6 times 2 is 12 times 2 is 24. Divided by 24, and I get 1,995,800. 19 million ways, almost 20 million ways to arrange the words, letters, and mathematical, and they all look different. They're all distinguishable. 6. How many ways are there to pick from 15 dolls, pick 4 and arrange. Since we're arranging, we're doing permutation. So there's 15 choices for the first, 14, 13, and 12, and that would be our answer. Or 15 NPR 4. And so 15 math NPR 4 is 32760. Or if we do 15 times 14 times 13 times 12, we get the same answer. 7. How many ways are there to select 4 light bulbs? Do I care what order? Do I care where they're arranged? No, I just got to pick 4. So that's combinations. From 100, pick 4. Well, that would be 100 ways to pick the first one. 99 times 98 times 97. There's my 4 that I picked. But those are first, second, third, fourth. So that's arranged. I got to get rid of the arrangement. So I got to divide by 4 factorial. And that's what that does. So I have 4 factorial is 4 times 3. 12 times 2 is 24. So I got to take this top number divided by 24. 100 times 99 times 98 times 97 divided by 24, and I get 3,921,225. 3,921,225. Let's just show you that that comes out to be 100 math probability NCR 4. Same number.